In the last two videos, I was explaining like how you can derive a function e to the power of f of x. Now, what I clearly stated is that the derivative of this is going to be e to the power f of x multiplied by the first derivative of the exponent. What I also stated is that if you are deriving something like a to the power f of x, this is going to be a to the power f of x multiplied by the first derivative of f multiplied by the natural log of this. What I clearly stated is that this must be a number. I clearly stated that a must be a number. But what if we don't have a number? What if we have a function raised to another function? I'm just going to say it's f of x to the power g n. What if I want to derive something like this? You clearly know that this is the last video I'm going to focus on exponential functions. So you basically have to know these rules, and now I'm going to prove the third rule to you right now. So what I'm going to do is take ln on both sides, and I'm going to have gx ln f of x. Then now d over dx of ln y, this will be d over dx of g at x multiplied by ln f of x. So now I derivate d over dx of ln y is going to be 1 over y dy over dx. Now here I'm going to just use the product rule. So using the product rule, you're going to have g prime of x multiplied by ln f of x plus g at x multiplied by the derivative of natural log of f of x. I'm going to prove this in another video, but for now just know that this is going to be f prime of x divided by f at x. So that's how you can derive this. So what this means is that I'm going to have, if I multiply both sides by y, if I multiply both sides by y, I'm going to have dy over dx. This is equals to y into g prime of x, the natural log of f of x, plus g at x multiplied by f prime of x divided by f of x. So that's what I'm going to have. Now, I'm going to have y. Do you agree that if I multiply this by 1, it's not going to change anything? Because multiplying any number by 1 is just going to give us that number. Meaning I can multiply this by 1 and it still won't change anything. But I know that f at x divided by f at x is basically 1. So I'm going to multiply this term by 1. And by 1 it's f of x divided by f of x. So I'm going to have g prime of x, natural log of f of x, multiplied by f of x divided by f of x, plus g at x multiplied by f prime of x divided by f of x. Now I'm going to go further now. When I have y, then I multiply this by this, so I'm going to have f of x multiplied by g prime of x multiplied by the natural log of f of x divided by f of x. Now when I have g at x times f prime of x divided by f of x on the side. So this is what I'm going to have. Now I'm going to further simplify this now. I'm going to have, what's my y? Y is equals to f of x to the power g at x. Now I can, since the denominators are the same now, I can basically just add this. I'm going to have f at x is the denominator. Then I'll have f of x multiplied by g prime of x multiplied by the natural log of f of x plus g at x times g at x times f prime of x. Now you can close the bracket there. Now this is a formula I'm going to use when you're finding the derivative of f at x to the power g at x. This is a formula you're going to use when you derive f of x to the power g at x. It's a formula you're going to use when you're deriving a function to the power of a function. Now, I know this formula is quite long. How you can memorize this is you can say, if I'm deriving a to the power b, this is going to be a to the power b multiply by a times b prime, multiply by the natural log of a, plus b multiplied by a prime divided by a. That's how you can memorize this, because with a's and b, it just kind of like makes everything shorter. But if you can memorize it like that, memorize it like that. Now, this formula, I'm going to use it when I'm deriving something like 2x to the power x plus 1. Let's say I want to find dy over dx. So I'm basically going to apply this formula. Anyway, you remember it, this is just the same thing. It's just that in this way, it's quite simple to remember because it's a very long formula. Now, what I'm going to do, I'm going to say that dy over dx is equal to 2x to the power x plus 1. According to the formula, you just copy it as it is. Then you multiply by, you divide by this one. Remember, I'm using this formula. Then I'm going to have 2x in the denominator. Then I'm going to have a, which is 2x, and I derivate x plus 1. You see that? I derivate x plus 1, and that derivative is going to be 1. Then I have to multiply it by the natural log of this. So I'll have natural log of 2x plus, now I have to have b, which is x plus 1, x plus 1. Then I have to derivate a. The derivative of 2x is 2, so I'm going to multiply this by 2. Let's see if I can further simplify this. dy over dx is going to be 2x to the power x plus 1 into, notice that in the numerator here, I have 2 on both terms. That means I can factor it out. And here on this term, when I factor 2 out, I'll have x times 1, which is x times the natural log of 2x. So I'll be left with x. I'll be left with x, the natural log of 2x. On this side, I'll be left with x plus 1. I'll be left with x plus 1, which you can include the brackets if you like, but it's still fine. Then I'm going to divide this by 2x. Now notice that these 2's will cancel, meaning that you'll be left with 2x to the power x plus 1 into x, the natural log of 2x, plus x plus 1 divided by x. And that's how you can derive this. That's how you can use this formula to derive any exponential function you have. Another example. Now let's say I want to derive y equals e to the power x plus 1. You still remember the formula? The formula says that if I'm deriving a to the power of b, this is going to be a to the power of b multiplied by a times the derivative of b times the natural log of a plus b, the derivative of a divided by a. And that's the formula you're going to use to derive this. Now, this means that dy over dx, this is the same as, you just copy it as it is, e to the x plus 1 to the power of x. Now, you multiply by a, by the way a is the base function, which is e to the power of x plus 1, multiply by the derivative of what's at top. The derivative of x is 1. Multiply by the natural log of e to the x plus 1 plus b, which is x times the derivative of the base. The derivative of e to the x plus 1. The derivative of e to the x is e to the x. The derivative of 1 is 0. So here I'm going to have e to the x. Remember, I'm going to divide this by e to the x plus 1. So that's basically what you're having. That's how you can derive such functions. So basically I'm going to have e to the x plus 1 to the x. Any number times 1 is that number. So I'm going to have e to the x plus 1 multiplied by the natural log of e to the x plus 1 plus x times e to the x divided by e to the x plus 1 plus 1. Now if you want to simplify this further, notice that I have e to the x plus 1 as a denominator, and I have e to the x plus 1 to the power x. What happens when you divide powers of the same base? You subtract the exponents. This is the same as to the power of 1. This means that to this x, we must subtract this 1. So that means I can simplify further and say it's e to the x plus 1 to the power of x minus 1 multiplied by e to the x plus 1 multiplied by the natural log of e to the x plus 1 plus x multiplied by e to the x. And that's how you can derivate this using this rule. It just simplifies everything. Just make sure you memorize it. Thanks for watching.